So, folks, today we are going to discuss an important topic regarding varignons theorem. Varignons theorem states that the sum of moments is equal to the uh, product of a resultant force into perpendicular distance. So if any number of loads acting on a particular beam, some loads acts downwards, some loads acts upward, right? So the resultant, there will be a resultant. Sum of all upward and downward forces gives the resultant. So the sum of all the moments, you know, moment, sum of all the moments is equal to the product of that resultant into a perpendicular distance where it is acting. So this theorem clearly tells you that where the resultant is acting, where, at what distance. So it tells you the magnitude and direction. See, this is such a uh, good concept for finding a resultant in a particular direction. So I am linking one good problem, so have a watch and have an understand of it. Thank you so much. Bye.
So folks, today I have done one problem regarding the variance theorem. Here I have written the statement. It states that the sum of moment of all forces is equal to the product of moment of a resultant force sigma ma equal to O and x. So we have taken one problem. So six parallel forces of magnitude 1000 Newton, 1500 Newton, 1800 Newton, 2000 Newton, 2400 Newton, 2700 Newton are acting at 1 meter, 3 meter, 5 meters, 7 meters and 8 meters from 1000 newtons. From 1000 newtons. You have to remember this. The forces first, third, fifth are acting upwards while others are acting downwards. Find the resultant of force analytically and direction, location at with respect to 1000 newtons. This is a problem. So this is the actual this we have to draw this. So first 1000 newton, then 1500, then 1800, then 2000, 2400, 2700, and the distances they are given is 1500 is 1 meter distance, whereas 1800 is 3 meter distance. That is already 1 meter is covered here. So again we'll write 2 meter. In such a way we have to write all the distances. And then what we should do is uh, we should give this uh, upward forces gives a positive, downward forces gives negative. Now what we have to find the resultant. What I said in the previous video, the resultant is a sum of upward and downward forces. So add all the sum of upward and downward forces. So 1000 is acting upward, so taken positive. 1500 is acting downward, so taken negative. Likewise, we get 1000 newtons acting downward, which means minus 1000 we got, which is 1000 newton acting downward. This is our resultant. This is our sum of the resultant. So now from varignons theorem, what we have to find? We have to find x at what location it is located. So we have to find the sum of moment at each and every point. So moment at 1000 is 1000 into perpendicular distance is 0, so we are not writing it. Now 1500 into 1, so 1500 is clockwise. So clockwise we have taken positive, anti-clockwise we have taken negative, right? In such a way that every moment, see 1800 is acting upward, and the moment it will take with respect to 1000 is anti-clockwise. So anti-clockwise negative. So we have taken negative, and we have written all the things like this, and we got finally 10,900 meter. This Newton meter. So this 10,900 Newton meter is sum of moments is equal to 1000 into x. Actually this resultant is acting downwards, so it is also taking a clockwise. So every clockwise will be negative. So clockwise will be positive. So we are taking a positive 1000 into x. So now we will find the x. X is 1009 by 1000. We got 10.9 meter. So the resultant is acting 10.9 meters away in a downward direction. Resultant is acting 10.9 away from 1000 meters in downward direction. This is what varignons theorem says. So you understood, I think. So please follow yours mechanical engineer YouTube channel. Have a good day. Take care. Bye bye.